When designing software, developers often face a crucial decision. Should we use inheritance or composition? This choice shapes how our code is structured, maintained, and extended. Both approaches have their strengths and weaknesses, and understanding them is key to building robust systems. In this video, we'll break down what inheritance and composition really mean, explore their differences, and see practical examples to help you decide which fits your needs. Let's start by understanding what inheritance is and why it's so commonly used in object-oriented programming. Inheritance allows one class to acquire behavior and properties from another class. Think of it as a family tree, where a child inherits traits from a parent. In programming, this means a subclass can use methods and fields defined in its superclass. For example, if we have a bird class with a fly method, a sparrow class can extend bird and automatically gain the ability to fly. This is known as a relationship. A sparrow is a bird. Inheritance is powerful for sharing common behavior, but it comes with some trade-offs, which we'll discuss next. While inheritance can simplify code by sharing behavior, it can also create tight coupling between classes. If the parent class changes, all subclasses are affected, even if the change doesn't make sense for every child. Imagine our bird class grows to support flying, swimming, gliding, and diving. Suddenly, every subclass, like penguin, inherits behaviors it shouldn't have, such as flying. This can lead to confusing code and bugs. Inheritance works best when the relationship truly represents but it can become a problem when forced into situations where it doesn't fit. Composition offers a different approach. Instead of inheriting behavior, a class is built using other objects that provide the needed functionality. In simple terms, inheritance is about while composition is about has. For example, a bird can have a fly behavior object. This means we can mix and match behaviors as needed, without forcing every bird to fly. Composition makes code more flexible and easier to maintain, especially as systems grow and requirements change. Let's look at a practical example. With composition, we define a fly behavior interface and create classes like can fly and cannot fly. Our bird class now has a fly behavior field, which is set when the bird is created. For instance, a sparrow gets can fly, while a penguin gets cannot fly. This way, flying is no longer assumed for every bird. We can change or extend behaviors without touching the bird class itself. This flexibility is a major advantage of composition over inheritance. With composition, behaviors can be changed independently of the main class. For example, if we want to add a new flying style or update how flying works, we simply create a new fly behavior implementation. The bird class doesn't need to change at all. This makes the codebase more modular and easier to test. It also prevents the problem of subclasses inheriting unwanted behaviors, as each bird only gets the behaviors it needs. Let's consider another example, notifications. Using inheritance, you might create email notification, SMS notification, and WhatsApp notification classes, all extending a notification-based class. As the system grows, this hierarchy can become hard to manage. Each new notification type means a new subclass, and changes to notification can ripple through all children. This approach can quickly become unwieldy in large systems. With composition, we define a message sender interface and create classes like email sender and SMS sender. The notification service class has a message sender field, allowing it to send notifications via any method. This means we can add new notification types, like WhatsApp or future services, without changing notification service. The code stays clean, flexible, and easy to extend. Composition shines when you need to support many variations without a tangled class hierarchy. So should you use inheritance or composition? If your relationship truly represents and won't change much, inheritance can be simple and effective. But if you need flexibility, want to avoid tight coupling, or expect requirements to evolve, composition is often the better choice. By understanding both approaches, you can design software that's easier to maintain, extend, and adapt. Remember, use inheritance for clear hierarchies and composition for flexibility and modularity.